Right, this video is all about how we use and apply the rules of surds to simplify expressions. So I'm going to talk you through 3 of the kind of key rules really with how we simplify surds. The first rule we're going to look at is what happens when we multiply 2 surds together and how we can use this rule in 2 different ways. So the rule is when you multiply root a by root b, you get the square root of a times b, all as 1. And we can use this rule in 2 ways. One, we can break up a big number into 2 smaller surds, or 2, we can times 2 small surds together to make a slightly bigger surd. So looking at this first example here, you can see that we've got root 50. Now because 50 is quite a big number with lots of factors, what we're going to do is we're going to look for the highest square factor, and that's critical when you're simplifying a surd, to look for the highest square factor. Because if you take out a square factor, then you'll be able to simplify that further. So if we think about root 50, 50 has factors 1, 5, 10, 25 and 50. The biggest factor that's a square number is 25. So we're going to write root 50 as the square root of 25 times the square root of 2. Because 25 times 2 is 50 and they're the factor pair that make 50. Notice how I wrote the square factor first, because we can now simplify that. Square root of 25 is just 5. So we can write that as 5 root 2, or 5 lots of root 2. Number 2 then, you can see, again, this was quite an easy example. We've got the square root of 2 times the square root of 3. And again, they're both prime numbers, so they haven't got any square factors. And therefore, root 2 times root 3 is just going to be root 6. We can't simplify that anymore because 6 only has 1 as a square factor, and by a rule there's no point in taking out 1 as a square factor because it's not going to simplify anymore. The third example using this rule looks at using the rule in 2 different ways. So you take the beginning, then let's have a look at simplifying root 3 times root 6. That's going to give us root 18 because 3 times 6 is 18. Now again, we've made the number bigger. We now need to look for any square factors. 18 has a square factor of 9, so I'm going to write that as the square root of 9 times the square root of 2. Because 9 times 2 is 18. Now the square root of 9 is simply 3, so I'm going to write that as 3 root 2. And we've simplified it there. The next rule we're going to look at is how we kind of add 2 surds together. Now this rule looks a lot more complicated than it actually is. A root x plus b root x is a plus b lots of root x. And the way in which I want you to try and think about this is think about an algebraic expression like 3x add 5x is 8 lots of x. If you've got a multiple of a root, you can just add the 2 multiples together. So here we've got, in our example, root 2 add 2 root 2. Well, root 2 is just 1 lot of root 2, and if you add 2 lots of root 2, that's going to make 3 lots of root 2, and we've simplified our answer. So the idea is that if you've got a multiple of a root, then you can add them together. If they're different surds, you cannot simplify them unless you break them up into a common square root of a number that is common to both of them, which we'll do later on in the problem solving activity. Our final rule then is the idea of when we divide 2 surds. So if you look in this example, we've got the square root of a divided by the square root of b, which again, similar to the multiplication rule where we can times the 2 numbers together, with the division rule we can divide the 2 numbers inside the root as well. So root a over root b is the square root of a all over b. And our example here states that the square root of 50 divided by the square root of 5, well, if we do 50 divided by 5, we get 10. So that's the square root of 10. And then have a quick inspection for your factor pairs for 10. You'll notice it has no square factors bigger than 1. So that is our fully simplified answer.